Hi, welcome to LeetCode. In this video, I am going to discuss LeetCode problem 3503, longest palindrome after substring concatenation 1. So you are given two strings S and T. Okay, you can create a new string by selecting a substring from S and a substring from T, then concatenating them in order. So first I will take the substring of S, then I will actually concatenate the substring of string T. So after this concatenation, we have to check that this is palindrome or not. So we have to return the length of the longest palindrome that can be found this way. So I will actually generate all possible this kind of string that are possible, substring from string S and substring from T. Then I will check that whichever actually the palindrome that actually maximum length or not. So we have to return the maximum length. So go to this example one, that will be more clear to understand the problem statement. So our S is A and T is again A. Okay. So what is the substring possible in this string is only A and another is empty. Correct. Empty is also a substring. Here also this for string T, we have only one character A and another actually possible substring is empty. Correct. Now we have to generate all possible substring from string S and substring from T. Then we check that whatever actually string ultimately after concatenation, what actually string we are getting, that actually palindrome or not. If it is palindrome, then we will actually try to maximize the length of that string. Okay. So suppose I actually have taken the string A from string S. Okay, and another I have taken this string A again from the string T. Okay, so ultimate string is AA. This is actually palindrome. So palindrome, what is palindrome? Palindrome is the string. Suppose A B C. This is our string. So if I reverse this string, then the string will be CBA. So if the input string and after reversing the input string both are actually equal, then we can say that this is a palindrome. So this is not equal. Why actually not equal? So first character here actually input string is A, but here actually it is C. Okay, so that's why if any one position, at least one position, if it is conflict or different, then actually we can't say this is a palindrome. Okay, suppose another example A B A. Okay, so this is our input string. If I reverse this string, what will be the string will look like? A B A again. So you can see that position by position here also A. In the after reversing the string first position also we actually have character A. Again next character is B. Here also next character is B. Next character is again A. Here also next character is again A. Now we actually reach the end of the string. So this is actually the palindrome because there is no conflict in any position. So this is actually that's why we can say this is actually palindrome. Got it? What actually what is palindrome? Now we are getting this string AA. So this is palindrome or not? So if I reverse this string, what will string do like again AA? So this first position also character is A. Here also the first position character is A. Here also next position the character is A. Here also the next position is A. So this is palindrome. Now what is the length of this? So our length here actually it is 2. So this is our till actually we are getting uh, only 2. The length of the maximum palindrome, length of the palindromic string, length of the palindrome string. So here it is 2. Now next any other combination we can do? Yes. Suppose we are taking one A from here and we are taking the empty from the substring of the tree T. So this actually ultimately A plus empty. So ultimately the string will look like again A. Got it? So A is palindrome. Yes, because if I reverse this string again, so this is again A because only one character is present. Now here also the character is A, here also the character is A. Correct? So both are actually equal. So there is no conflict. So now this is palindrome. So what is the length of this string? Palindromic string length is 1. But till now, what is the maximum length? Actually, I've seen 2. So do I need to take this as a consider? No, because we already have seen 2 length 2. So why actually we're taking? We will take 1. Got it? Next, another combination is possible. Yes. Now we are taking suppose this empty from the string S, empty substring, and this A from the string T. Got it? So this is a string look like first from the string S we are taking empty, and from string T we are taking A. So our string will look like A again. Similarly, this case actually again. So if I reverse this again, so this will A both are actually A, and there is no conflict, so both are actually palindrome. Here length is 1, so we will not consider this because we already have seen length 2. Okay, next, this actually suppose you are taking empty from the string S and also empty substring from the string T. So this is still, so after if you concatenate this again, this will be empty because whatever taking from the string T, this is, that is also empty, and whatever we are taking from string T, that is also empty. So ultimately this is an empty string after concatenating. So there is no character, so we can't say this is a palindrome or not. So we will not actually consider this because there is no character. So I will not do anything. Any other combination is possible? No. So that's why for this example the answer is 2. Clear? Why answer is 2 here? Example 1. So suppose next example is A B C D E F. Suppose take another example. Suppose here actually it is B A A A. String S is B and T is A 4A. Okay. So what is the substring possible in string S? That actually one is B, another is empty. Correct. For this T, what is actually possible? Substring are possible. One is starting from this A, so this will be A, and A. So this is starting from this A. Next again this can be starting from this A, so this will be again A, 2A, then 3A. Then we can start from this A, so this will be A. Now we can start from this A, so this will ultimately A. So this is all possible substring that we can generate from the string T. Got it? So you all know how can I generate all possible substring from a string inputs, any string, correct? So this will be actually n square. So one is the fixing the substring, the left index of the substring, and another is we are actually shifting the right pointer from left to right. That will generate the ending of the current substring. Correct? Here actually you can see that the left and right both actually index pointing at the index 0. Next is 0 and 1. Here it is 0 and 2. It is 0 and 3. Got it? Here actually again 1. Here is 1, 2, 1, 3. Here actually it is 2. Here is 2, 3. Here is 3, 3. Got it? How is it taking? Here actually first we are actually fixing the left pointer of the current substring. Then we are actually iterating, go up to the r less than n. Then again we are actually shifting the left pointer to the next l plus 1. Got it? So this is n square time complexity to generate all possible substring. Correct? Now we actually have these two things. One is for all possible substring of string S, another is for all possible substring of string T. Now what we'll do? First we will take one B from string S. Okay, this one possible substring, and I will check all possible combination. Here is from A, then AA, like in this B plus A, then B plus AA, then B plus A. In this B plus A. In this actually, got it? All possible substring I have to check. I will check all combination. Then I will check that okay, after this concatenation, is this string actually palindrome or not? If it is palindrome, then I will check what is the length of this after concatenation. Then I will compare with our global answer variable that we have to return. That is the maximum length actually I can actually get. Correct? Got it? So what is the step for this? So got the intuition right? How actually we can solve this problem in brute force approach? First of all, generate all possible substring from S and T. Correct? So this will take actually big of n square time complexity. Correct? Big of n square. I've already explained. You can also see that way to generate all possible substring from his input string S. Okay. Now for this two string, we actually have all the possible substring. Now what I'll do? I will suppose for this string S, I actually have m1 number of substring. Okay. For T, I actually have n1 number of substring. Got it? Now what I'll do? I will check for each S or each substring of S, all possible substring of T. I will check all possible combinations. So that's why that I'm actually m1 into n1. Got it? Big of, because what I'll do? First of all, I will take one element, one substring from S and one substring from T. Then I will do substring 1 plus substring 2. Then I'll check this actually palindrome or not. So this is 2, check all possible um, to generate all possible combination. Correct. Now, when I'm actually getting one string after concatenation, I have to check that this actually palindrome or not. So how actually do that? So I have to actually check each position that this actually character actually after reversing this actually same or different. If it is different, then return false. This is not a palindrome. If it is true, go to the next index. Right. If you reach the end, then this actually palindrome. Correct. So that's why I have to iterate each character. So this will be big of L if the length of the string is L. So this will be M1 into N1 into L. Correct. The steps is clear. First of all, generate all possible substring of string S and string T. So suppose I now actually have M1 number of substring in S, string S, and N1 number of substring in T, string T. So now M1 cross N1, I will generate all possible combination substring from S and substring from T. Correct. Now for each uh, concatenation, after each concatenation, I have to check that this character, this string actually is palindrome or not. Whatever actually string actually we will generate. So that's why for that to check that the palindrome or not, it will take actually L time velocity, big of L, length of the string, length of the string. So that's why this time velocity will be ultimately M1 cross N1 cross L. Got it? This is clear. Now if it is palindrome, then I will store this as a, in the answer global answer variable, whatever the maximum length. Clear? And ultimately return that. Now go to the code. So first of all, what is the step? First step is generate all possible substring of string S and string T. So what I have taken two factor, one for substring of S, another for substring of string T. So I know that empty string is always a part of the substring of any string. So that's why I have actually inserted this empty substring into the substring of S and substring of T vector. Got it? Now what I'll do, I'll generate all possible substring. So in by n square, I will generate all possible substring of S, and by n square again, I'll generate all possible substring of T. So this I is actually fixing the left pointer of the substring, starting of the starting index of the current substring, and J is pointing the ending of the current substring. Got it? So you can see that I is starting from 0, I less than S dot size, and J is starting from J is equal to I, J less than S dot size, and J plus plus. And I'm storing this in the substring of I to the length J minus I plus 1, and I'm storing this in the substring of S vector. And similarly for the substring of T, starting with I is equal to 0, J is equal to I, J actually increasing up to J less than N, whatever the length of the string T, and J plus plus. And I'm storing the current substring starting with index I, and the length is a J minus I plus 1. So now after this these two for loop, we actually have the substring of all possible substring of substring S, string S, and the substring of string T. Correct? Now we have to return the answer. What have to return? The maximum length of the palindromic string possible to generate. So what I'll do, I actually take one substring from substring of S and one substring from string T. So that's why you can see that here we have taken two nested for loop. One is for this A is the taking the substring from string S, and B is the substring from string T. Now after concatenation, this string will be look like A plus B. They've said that we have to maintain the order. You can see that in order means substring from A first, or string first is first, then substring from T. Got it? So that's why I actually added this A plus B in this order. Got it? Now I will check that this is actually empty or not. Both are actually empty. So I've already explained, if both are actually empty, substring of S and the substring of T, both are empty, then there is no character. We can't say this is a palindrome or not. So that's why I will not consider that. So that's why I'm checking that this is actually empty or not, current string. If it is not empty, then I will check it that the current, whatever the current strings we have generated from the string after substring from S and substring from T. If it is palindrome, then I will check that what is the length of the current string. If it is maximum, then store into the answer variable. And ultimately, after checking all possible combination, I'll return the answer variable, whatever the store actually maximum length actually I have palindrome. So how is checking that this is palindrome or not? Whatever string actually I have. So this function actually taking a string variable, and I have taken 2 pointer. One is the left pointer, another is the right pointer. While left less than right, you can do the same way, that first reverse the input string, another string, temporary string, that is a reverse of the input string, then index by index you can compare that. But instead of taking a temporary string, I am actually using only one input string only. So I've taken two pointer, one is the left pointer and the right pointer. Ultimately reversing, after reversing we're actually comparing the first with the last character, right? So that's why check that if the current character present in the left pointer that is not equal to the current character present in the right index, if it is not equal, then return false. Else left shifted to the right and right shifted to the left index once, and ultimately till our actually left less than right, we will continue to check, and whenever check complete the check, I will return true because there is no conflict. So return true means this is a palindrome. Got it? So you can see that. So I've already shared this code in the description. You can check that. Now go to the time study. So what is the time study for this steps algorithm? So first of all, this actually n square to generate all possible substring of string S. Similarly, for this is the n square to generate all possible substring of string T. So till now, time study big of n square roughly. Now what you're doing, we're taking checking all possible combinations. So one for the substring S and another for the substring T. So this will be m cross n, and for if we're checking each palindrome, so this will take big of L. Got it? There is no any other for loop. So that's the time study will be m into n into L. So ultimately time study will be what? Here the length of the string is 30. So 30 into 30 into 30 maximum roughly. So it will take actually uh, 927 into 10 to the power 3. So it will 3 into 10 to the power 4. Clear? Now this is a time complexity. Any space complexity? Yes, we are to generate all possible substring. So the number of substring are possible. Big of n into n. So this will be n square tangle space complexity. This is space complexity. How many actually suppose here actually three character A B C. How many actually substring are possible? One is A, and there is A B C, then B C, then C. So 6. So this actually you can see that first actually have 3 option, then actually have 2 option, 1 option. In this I can say that 1 plus 2 plus n. So this will be n into n plus 1 by 2. This number actually substring are possible. You can see that 3 into 4 by 2. So 6. Got it? Here's a 6 substring are possible. Clear? Because with you can actually relate this that for A, how many actually substring are possible? One is A, then B, then C. Means how many characters are present on the right side. So this is ultimately 3. Similarly for B, how many right characters are present? 2, B and C. Similarly for C, there is only one character present, C only. So if there is n characters, so first character will have n option, then next character will n minus 1. So till now it will go up to 1. So if you reverse the thing, then it will 1 plus 2 plus in this till n. Got it? So this is clear. So if you like the explanation, please like the video, and if you have any doubt, any suggestion, you should comment on that. Thank you, and if you're not yet subscribed, please subscribe the channel. Okay, bye.